Hello algebra students, and welcome back to another video lesson where we explore using Desmos to create regression lines or lines of best fit. Not necessarily lines, but best fit equations for data, be it linear, exponential, or quadratic, and use those equations to help us make predictions. Yesterday, you worked a little bit on a Desmos activity with pennies and trying to fit pennies inside of a circle. And if we enlarged the circle, how many pennies could we fit and stuff. So we'll use that a little bit in today's video as well. But a lot of this is going to be on Desmos, and I'm going to warn you ahead of time. There's a lot of notes and formulas that you need. Yes, need to write down. We've done a little bit of this in the past, though, on Desmos. And so if we've got a certain set of data, where this is a car plant electricity usage data set, we can use this set of information to create an equation of best fit, an equation that will represent this line or this information the best. And so I'm going to label electricity usage as my x-axis and my production as my y. And so I need to put that into a table into Desmos. All right, and I've already done that to save us a little bit of time. Here's the x1 and here's the y1 from, again, directly from this table. Okay, I punched in the x's and then I punched in the y's. And so you'll see we get this type of a scatter plot over here. And I did change my window, but I can zoom in a little bit more if I wanted to. Now, in our line here for number 2, we got to leave the table there. But here in number 2, we type in y and then the number 1. And just by typing in 1, it automatically puts it down a little bit lower. And then we want this, instead of an equation sign, we want this little squiggly line, which is shift. And it's the button next to 1. So we want that. And then this looks like it's a linear pattern, or y equals mx plus b. So instead of mx plus b, we have to do mx1 plus b. And you will then see, let me get myself out of the way. You will then see over here that we have information, right? I can grab all of this information down here. And in fact, let's do that. Let's grab all of that to create the equation that would fit this data, so to speak. All right, and so if I put it in here, remember we said it was linear, and linear is typically the equation y equals mx plus b. And we can grab from that Desmos graph, that prediction line that they gave us, this regression line, and use their information to create the equation of a line. Y equals 1.61x plus 0.31. And if I wanted to, I could certainly use this information in this equation to predict in 2 years how much might the production be and things like that. Okay, and so what we've got to figure out are all of these different equations and different ways that I can punch information into Desmos if I have a table that will help me. And that's really what we are focusing on. There are 3 types of regression that we have to be able to recognize. One of them, as we've talked about, is linear. It looks like it's a straight line, left, right, up, down, either way. Then we have exponential, where it starts out really, really, really high and it gets smaller, smaller, smaller. Or, maybe it goes this way. It starts out low and gets really, really high. Versus then quadratic, which is what we've been working on a lot, where all of a sudden we start and get this pattern where it starts to curve back down. It increases and then all of a sudden starts to decrease. Almost where it looks like it's, 2 lines, where if I drew a line this way and then maybe there was another line that way, well, that's going to be quadratic because there's that change in patterns. Now, each one of these 3, linear, exponential, and quadratic, are going to have their own unique way of typing that function part, which I typed in down here. We have to know what that formula is to type in. So the next 3 slides are probably the most important in terms of giving you directions and what that formula is. So this one is for linear regression, okay? The linear regression. You need to enter in the data, okay? And to enter in data, I'm going to get rid of all of this stuff on this page. To enter in the data, I click the plus sign and I say I want to enter it into a table. And I enter in all of my data into the table and we start entering it. As we do that, it's going to plot the information and we need to adjust our window. And then we need to determine, is this linear? Is this exponential? Is this quadratic? We need to just to figure out which one of these three is it. Because once I figure out which one of those three, we've got to then use this is called the coding. Okay, this is the code, if you will, that we need to enter for linear. If it looks like a linear, then this is the code that we use. And you just type it, Y1, that little squiggly line, which is right next to the number 1, mx1 plus b. You type that in. After you type it in, it will give you the information right next to it. If it is a exponential regression, where it's just starting out low and then increasing, or vice versa, the code for exponential, everything else is the same. We followed the exact same patterns until we get to here, and then the code that you type in for exponential is this one. All right, and this one's a little bit maybe trickier, I guess. A little bit trickier for us to type in. Just a little bit. Not horrible. In this one, it's still going to be Y and then the 1 and then that squiggly line and then A and then B. But on your computer, you got to find this caret button, this up. I think it's Shift and number 6. And then you do X1. And that's the way you type it in. All right, you have to move this X part to the exponent, which is that. And yet it still gives us information to utilize. It's going to give us the A and it's going to give us the B values for us to plug in to our equation if we have it. And then your last one for coding for quadratic. If it looks like a quadratic function, here is the code for quadratic. Y1, that squiggly mark, AX1 squared plus BX1 plus C. This is by far the trickiest one to type in. So we're going to type in Y, then the number 1, then your squiggly mark, then A, then X1, and then this up arrow for 2, that Shift 6, I think that's called, plus BX1 plus C. And that's how we're going to have to type it in order for the system to generate the code and give us that information. So let's, again, if you didn't get any of those down, I'm going to go backwards one at a time. Pause and make sure you've got that code down and make sure you wrote those steps down. Okay, that's linear. Here's exponential. I would pause the video and write that down. All right, and then here's quadratic. I would pause and make sure you get that down as well. So here's an example. I am working out of your packet, page 4 of that new packet, warm-up number 1. This table shows the enrollment of a preschool from 1980 through 2000. And it tells us to use the year as X and the enrollment as Y. So we've got 1980 was 14, 1985 had 20, and then in 1990 the preschool had 22, and then in 1995 the preschool had 28, and then in 2000 the preschool had 37. So we need to go and enter that over here on Desmos. Okay, and again, I'm going to enter a table by adding a table. X1 was 1980, and in that year they had 14 students. Then in 1985, they had 20 students. And then I'm just going to keep plugging that information into my table. That would be 1990, 1995, they had 28. And then again in 2000, they had 37. Now you'll notice my window starts at 0 and it goes up to around 6, 7 over here and up to 7. But the X values start at 1,980. And the Y values start at 14. So I'm going to go up to this gear, and I'm going to change the X-axis. So I'm going to get rid of all of that. The smallest year was 1980. So I'm going to start at 1975, and then I'm going to go all the way up to 2020 to oops, won't let me delete. There we go. Like to 2020. And you'll see it change my axis down here. And then my Y values, again, for our Y values, our smallest one in our table is 14. So we'll start at 0. And then we'll go all the way up. The highest one is 37. So we'll just go up to like 50. And there you can now see those points plotted. Now, if you ask me, which one of those three does it look like? Linear, exponential, or quadratic? This is definitely linear. It looks to be more of a straight line, where an exponential is going to start low, 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 and then get really, really high fast. And we don't have a change in direction up or down. So that means we can type in the linear one, y1, right? And I'm just typing in the y, then the number 1. Whoops, not up there though, Mr. G. Right here in number 2, we got to create a new line. So y, then the number 1, shift, and the button next to number 1, mx1 plus the b. And there's a line that they're using to approximate that information. So if we go back, all right, if we go back to the Jamboard and uncover this rectangle in the bottom, you can see I copied a lot of that same information over, brought it over, and here we go. They're telling me the M value is 1.08 and the B value 13.4. So Y equals, instead of M, it's suggested that we have 1.08x plus the B value of 13.4. So we can use that to then predict certain things, right? Predict what the enrollment will be in 2015. So I'm going to take 1.08 and multiply that by 2015 and add 13.4. Now you can do that on a calculator. You can go back to Desmos and type that in. Either way, it's going to give you about the same exact answer. And if I do it on my calculator here on my phone, whoops, 1.08 times 2015 plus 13.4, it says that we're going to have roughly 2,000 people. Something does not seem quite right. Excuse me for a moment. That's not the right equation. Why is it not? Because we use different values, right? The B value for ours, if I just plugged it in 1980, 1985, was negative 2,125. So let me erase that. Negative 2,125. Negative 2,125. So instead of 13.4, we needed to use that same value. All right, and so now if we do it correctly, and we take away the 2,125, we should get about 51.2. Okay. 51.2. And again, I could plug that in over here. Y equals my M value 1.08 times my 2015 minus the B value of 2125, and you'll notice that it did give me 5,000 or 51.2. Right, because it's using the M value here and the B value there in our equation. Now we can also use it to predict when will the enrollment be 90. When will all of this equal 90? And so instead of doing it with a Y, we could type it in with just the X and plug in 90 for that Y value. Now again, we can use algebra to work backwards and solve, or we can go over here and say 90 will equal 1.08x minus the 2,125. Now you'll notice it doesn't necessarily give me a specific value. So instead, when will y equal 90? And I could scroll way up here on the graph and find where that y value is 90. Where's y 90? Way, way, way over here at about year 2050, 2051. Okay. And again, you can use your algebra skills backwards to solve that. Now, yesterday, and again, I apologize that this video is getting a little bit longer, but take a break if you need to and pause, and come back if you have to. It's all right to take a break and just, kind of make sure you understand what it is. Now, here's an example from yesterday's penny circle regression, right? The larger the diameter of the circle got, we probably could fit more pennies into it, right? And so this is what one student collected. And so we're going to go and punch this in to Desmos. And then we're going to see if we can use that to predict certain information. So I'm going to clear all of the information I had from the previous one. I'm going to even delete that table. I'm going to add a new table. Did it tell us what to use for X or Y? No. So let's say X would be the diameter. We had a 2.6 diameter circle. We fit in about 8 pennies. And when it was a 2 diameter circle, we filled in about 4. 1.2 circle gave us 1. And a 3 diameter circle gave us 11. Now we got to adjust our window again. Our x-axis could have started very well at like 0 because of 0 diameter for a penny, all the way up to, let's just say, 10. Excuse me. Our y-axis, we could start at 0, and we have a high of 11 pennies. So let's just say that we go up then maybe to, 12 pennies. And you can see, I have my 4 points, that they are increasing very rapidly. It looks like it might be linear, but it's actually going to be exponential in this one. We want to look at an exponential pattern. Actually, we might even want to look at it as a quadratic, because the more that we start to add, we might not get quite as high as we want. And so I'm going to use this one as a quadratic, just so you can see how I would type this one in. Y equals, or that exclamation point, a x1 to the second plus bx1 plus c. Now, it's going to give me this little warning. Y may not be used as a regression parameter. Try using a list. And so if I go back to the code, I think I missed putting in y sub 1. I only put in that y value. So if I go back to the y and we just type in a 1, boom. And there is that pattern. And that looks like it actually fits that line pretty darn good, right? It's going to fit it pretty darn good. So there's my A, my B, and my C values, which, again, I already copied those onto another page. So we have those A, B, and C values that I just got, 1.71 for A, 1.57 for B, and 0.4 for C. Okay, they're right there from the parameters. We use those to create our quadratic equation, and then we can predict what a 22-inch circle might give us by plugging in 22 for both of those x values. And in this case, we could fit in, it looks like 793 pennies in a 22-inch circle. And so again, you need to make sure that you have these codes written down for inside of Desmos so that when you've plotted the information in Desmos through your table, you can use them to predict. If you have any questions as you're typing this stuff in, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.